Oh, hey there, kids. I'm Cody Keller, the chemistry fella.
Mr. Keller, I don't understand chemistry.
Well, then you've come to the right place. First, we're going to learn ionic compounds. An ionic compound is when a metal and a non-metal are combined. The metal is always named first. Now, for the non-metal, the ending changes. It changes to I. In the end, you get potassium chloride. Now, for naming the formula. First, you find the letter affiliated with the compound on your table of elements. Then you get the non-metal. Using the crisscross method, you take the positive charge of the metal and bring it next to the non-metal, and you take the negative charge of the non-metal and bring it down to the metal. Whenever there's a 1 or the same number, whoop, whoop, you erase it. These are the correct ways of writing potassium chloride. Now you can do them at home. Next, we're going to be learning about a multivalent ionic compound. Now, multivalent means that the element has more than one possible charge. When the compound is put into words, the charge is given to you in Roman numerals. As seen here, the gold has a charge of +3. Putting it into the formula, you take the charge given to you in the name and do the old crisscross method. The charge of the gold is next to the fluoride, and the one little lady. Do you understand?
I do.
Next, we're going to be learning about polyatomic ionic compounds.
What's a polyatomic ion?
Great question. Now, polyatomic is broken down into 2 words. Poly, meaning many, atomic, atoms. So many atoms together. Now the thing is with polyatomics is that they don't like to break apart so easily. Does that answer your question?
Yes.
Now with polyatomic ions, you do not change the ending to I. You leave it the same. With polyatomics, you still use the crisscross method. Taking the positive charge of the metal over here, the negative charge over here. But you do not
So H is hydro, Cl
just
is
add
chlorine.
the
So
charge.
H becomes hydro.
You have to put
Cl
a
becomes chloride
bracket,
with an acid in the
add
end.
that bad boy.
Not chloride, it's chlorine because it's an acid.
Next, we're doing covalent compounds, which is when a non-metal and a non-metal come together. Now, when you're giving the name of a covalent compound, you already know the charge if it's given to you in the prefix, di, meaning 2. So this would very simply be C for carbon, and the oxide, O, and you already have the di, meaning 2. Now, little one, why didn't I put mono before carbon?
Because you never put mono on the first one. Duh.
I don't like your attitude. You should come teach the class.
No.
Wait!
Really?
Yeah.
So pretty much, we're trying nitrogen peroxide. All you do is this is 3 and this is 5, so it's N3O5. You remember, mono equal 1, di equal 2, tri equal 3, tetra equal 4, penta equal 5, hexa equal 6, hepta equal 7, octa equal 8, nona equal 9, and deca equal 10.
Learning about acids with simple anions. Now, an acid is when hydrogen combines with a non-metal. In this case, hydrogen is combining with bromine. Now, the ending, if it ends in INE, you would change that to just IC, and the hydrogen just changed to hydro. So in the end, you would get hydro, and then bromine, changing the end to ic, bromic, and always say acid. This, my friend, hydrobromic acid. And certainly not least, hydrates. Now, hydrates are compounds which include water molecules in their crystal structure. What I do is get you to teach the class.
Uh-oh. Okay. So, from what I've learned is that we're pretty much just doing an ionic compound. So this is iron 3, sulfate, and this is a hydrate. When you name it, it would look like iron 3 with your Roman numerals, sulfate, and this is called a hydrate. And since this is the letters or the number 6, it'd be a hexahydrate.
Correct. Change it from the name to the formula is rather simple. Copper, copper 2, so it's copper, the charge of plus 2, plus sulfate, which is SO4, has a charge of negative 2. And you do the simple crisscross, which means A equals CuSO4. And now you have to add the hydrate. Now this is a tri-3 hydrate, so it would be 3 hydrogen, or 3 water molecules. So you add this little dot, which means that you're adding the hydrogen particles, 3, because it's tri, and H2O, because you're adding the hydrate.
And everything now